Okay. Go to your Canvas page. Under announcements, there's a welcome announcement. The welcome announcement tells you to enroll in MyOpenMath. It gives you the link and the codes you need to do that. Do that. You follow the instructions in MyOpenMath that lead you to the introduction to MyOpenMath, the ABC exercise, and additional. Now for tomorrow, and to tell you the truth, I've got 3 classes that are all using MyOpenMath, and I should have had this one open. Where in the world is it? It's real easy, quick to navigate. So here it is. Here we go. Here we have it. Okay. Now what I'm looking at is the calendar. Calendar and a grade book. Calendar tells you what assignment is due, what day and when it's due. In MyOpenMath, you can be a day or so late 5 times. Okay. After that, there will be a site where you can go to get half credit. Okay. Your homework in MyOpenMath will be a certain percent of your grade. Okay. I'm not going to tell you what that percent is. Might be 10%, might be 15, might even be size 20, somewhere in that range. It's not a big deal, but it's important. The reason I'm not going to tell you, I want you to read the syllabus and find out for yourself. Okay. So I'm not going to stand up here and read the syllabus to you the first day. You read it and then we'll talk about it next time. Okay. It'll make more sense to you after you've gotten through it. Give you the whole syllabus right now, and you won't know half of what it means. After you've gotten your feet wet, it takes one more minute. So you do want to read the syllabus. That's part of the implicit assignment. Okay. Again, you have the calendar and the grade book. Grade book will tell you what your grades are. You know, for the first few weeks of the course, you will not have had a real test. So you're going to have grades for your homework. You're not really going to know how you're doing, because it's only maybe 15% of your total grade. Again, you figure out what you're total. Okay. The way it's set up right now, there's a major quiz that usually takes place later this next month, later in September. A midterm that takes place around the midterm, the 3rd week of October, and a final exam. Those would be the bulk of your grades. Okay. Now, every day you come in here, you're going to expect to have a quiz over the material you did for homework. Okay. That gives you a pretty good idea how you're doing, gives me a pretty good idea how you're doing. Tells me how to gauge the class, tells me how to approach things. I see people not doing well here, well, try to address it. What I recommend is get to the MyOpenMath page, see what it says, have a calendar and a grade book, take a look at those. I'm going to look at the calendar, just tell you what I've set up, which is for today, before midnight. I better check my times on these things. Before midnight, 11:59. You need to do the introduction to MyOpenMath and the ABC exercise. The ABC exercise, send me a picture of your work and then bring it to class. Okay. Scans are better than pictures. If you have a scan app in your camera, it gives you better quality. But pictures, if you got the lighting right and quite dark, they're legible. Okay. And if they're not legible, that's okay. I can look at them when you bring it to class. At least I know you did it. But I want to get a sense of how people do on it. It's really easy. Almost everybody gets everything correct on it. Doesn't take long. Okay. For tomorrow, you have assignments on exponents and fractions. Now that's not pre-calculus. That's elementary algebra. Okay. Actually, that's fifth grade arithmetic. But the problem with fifth grade arithmetic is nobody really knows it because after fifth grade, they put a calculator in your hand and you never do it again. Really stupid way to teach math. But it's kind of ingrained nationwide. We do math in a stupid way. We teach it in a way that nobody understands what they're doing. Okay, try to remedy some of that here. And much of what you get is good, but we're going to do kind of a little quiz here. Not a quiz, just an exercise. I want you to work out some problems. Okay. So I want to kind of gauge the class. Okay. Then for Thursday, you have your first written assignment where you introduce yourself. And for Friday, you have an assignment, 5 most basic functions. Then I kind of give you a break, nothing to do until next. Actually, right now, it looks like Wednesday, but it's going to be Tuesday. Okay. All right, now, one thing in class, I'm going to post these videos of what we're doing. So I want to emphasize that one way or another, you got to get those algebra skills upgraded, and I can't do that for you. Okay. Now we do have the MARC, Moose Academic Resources Center in the library. I think they've got tutors. Okay. They had great math tutors, but a lot of them were engineering students. They went into their second year engineering courses, including a couple of mine. And I realized they really need to concentrate on their second year engineering courses. So they can't tutor anymore. So I'm not sure what their status is. But they're committed to being able to offer tutoring and help. So that's the first place you want to go if you want to upgrade your algebra. Okay. We also have the MDE 60 course, which is an elementary and intermediate algebra course. Now, I don't think most of you need that, although some of you do, and you might find out that you really need to do that before you attempt for calculus. Okay, it's the reality. In typical pre-calculus class, only a third of the people who start succeed. Partly because of lack of previous preparation, partly because of being too busy to spend the time, or too sorry to spend the time. I was kind of sorry in my first year. Okay, so no shame in that. Of course, you don't necessarily want to end up like me, so don't be sorry. Excuse me. First couple of days back, talking loosens up everything that's been there in my sinuses all summer. And it ends up in my voice box. So as I was saying, okay, we have the MDE 60. That's a very good course. That course works pretty well. We have the MDE 61, which is a support course for this, where you get a more gentle introduction to every topic before you see it in pre-calculus, so that you don't sit in pre-calculus class and everything goes over your head. Okay. It's a small class right now, and it probably will stay small, so you get a lot of individual attention. if you find over the next week or so that the algebra demands are overwhelming you, you should really consider first talking to me to see what I think your status is. And at least the MDE 61 class. Okay, if you take the MDE 6, you can't even be in this class. The MDE 61, you can do both. Now, it might be you're just rusty. You have to get the rest out. I have to know these things, okay? These are elementary algebra for the most part, not even intermediate algebra. And I didn't look at all the things. I looked at about 10 papers, and it looked like some of them looked pretty good, but it looked like most of you have a ways to go. Got to get that out of your way or you keep stumbling over it, okay? So these early assignments. Another thing I do in this course, though, is I kind of concentrate on graphs early in the course to give you a chance to bring your algebra up to speed. Okay? Because the graphs show you what everything means. And then it's just a matter of cranking the algebra out. So acknowledging that people generally come in here with poor algebra preparation. And that's especially true if you had your algebra online because of COVID. Many of you did. Okay, COVID's interfered with a lot of things, but it's not going to change the standards of this course. Be aware of it. Okay. Just briefly, I'm not going to work this for you. I'm just going to point to you and tell you what you should know already. Okay. And I'm not putting you down because you don't know it. I'm just, nobody knows it really. Well, yeah, some of you do. But most people coming into the calculus course just don't know it. Okay. Well, that's 12/8, right? You know, tear a piece of paper into 8 pieces, take 7 of them, that's 7/8. Leaves you one. Well, tear another one into 8 pieces, take 4 of those and put it with the one you got. And then how many pieces you got? You got 7 of these, you got 5 of these, and that gives you 12/8. That reduces down to 3 halves. That's easy. And you multiply fractions. You multiply the numerators and you multiply the denominators. You don't punch it into your calculator. Put that calculator away, except for things like multiplying 3-digit numbers and stuff like that. That's a perfectly valid use of the calculator. Doing fractions on a calculator is not valid. Doing it on a computer algebra system is not valid. It doesn't teach you anything. It doesn't give you a basis for understanding what happens around the 3rd week of October in this course. Okay? Get rid of it. Well, don't get rid of it. It's probably your phone. You probably really don't want to live without a phone. Most people get along just fine if it wasn't this 2-factor authentication and the possibility of emergencies. Okay, well, another thing while I'm talking about how to approach the course, don't let Chegg do your homework for you. I guarantee you, if you do, you're going to fail. You're not going to have Chegg with you in the exam. You're not going to even have your calculator with you in the exam. You have a stripped down calculator to do arithmetic and pretty much nothing else. Okay. And exams are administered in the testing center. More about that when we get to the exam. Okay. 7/8 divided by 5/8, you invert the divisor and multiply. So 7/8 times 8/5. Okay. Turns out it gives you 7/5. Okay. X to the squared plus x to the 4th equals x squared plus x to the 4th, unless you factor it. The only thing you can really do with this is say that's x squared times 1 plus x squared. X squared times x to the 4th is x to the 6th. Because x squared is x times x. X to the 4th is x times x times x times x. 1, 2, 3, 4, 5, 6 x's. That's x to the 6th. X squared y times x cubed minus y squared. The distributive law tells you that this is x squared y times x cubed minus x squared y times y squared. And that equals then x squared times x cubed, just like up here. You got two x's here, you got three x's there, that's 5. You got x to the 5th y and x squared. And you got a y here and 2 up here, that gives you y cubed. X squared y to the 3rd. That's x squared y times x squared y times x squared y. Now, when I post the video, you'll be able to see that easier if you're in the back or your eyes are not great. But I'm doing this very quickly, so you might want to refer to it. That's x times x, that's x times x, that's x times x. How many x's is that? Show me the finger. You got x times x, you got x times x, you got x times x. How many? 6. Okay. You have to understand that because it's too easy to mess up the laws of exponents. You confuse one rule with another. It's very confusing unless you understand what you're doing. And unfortunately, the way math is usually taught in the schools, nationwide, and I'm not just talking about your school or your teacher or anybody, you teach it, you memorize the laws, you use them, you forget them. You never understand them, so they don't stick with you. In this course, we're going to work on understanding what's going on, so it sticks with you. So when you take subsequent courses that rely on this one, you have something that you can actually use to help you learn. You have something you can actually build on instead of a bunch of habits that you memorize. Okay? Memorization's okay. Anyhow, you got 3 y's, so that's a y cubed. 4 to the negative 3. I'm not going to bet that nobody got this. There are a lot of you in here, and some of you look like you got terrible bad. Negative x, that's 1 over 4 to the 3rd. X to the 6 times x to the 6. Actually, negative 6 times x to the 6. Well, one law of exponents tells you that that's x to the negative 6 plus 6. Negative 6 plus 6 is what? 0. Okay, that's x to the 0. X to the 0. Show me with your hands, 1 hand, 2, 3, whatever. What x to the 0 is. Okay, is that a middle finger? Okay, x to the 0 is 1. There's a strong temptation to say it's 0. It should be drilled into you pretty well, but in my experience is it isn't. At least half students will tell me x to the 0 is 0. Okay, multiply by 0, you get 0, but that's not multiplying. It's got to be 0 because we could also say, that's one way to do it. Another way is x to the negative 6 is 1 over x to the 6. And we could write x to the 6 here as x to the 6 over 1. We use the rule for multiplying fractions. 1 times x to the 6 is x to the 6. And that's what we get in the denominator too. And that equals 1. Okay. So if this one doesn't equal 1, if this one equals 0, this one has to be 1. And all of a sudden mathematics is inconsistent. And our whole civilization crumbles. Okay. Yeah, well, that's not the case. So fortunately, that works. This is the application of the distributive law. Don't have room to write it out, so I'm not going to. You have to know the distributive law, but I use it here. X minus y times x minus y is x minus y times x minus x minus y times y. It's this times this, and this times this. And x minus y times x is x times x minus y times x. X minus y times y is x times y minus y times y. And that's x squared I got a sign here, Bob. Let's see. Yeah, it's x minus y times negative y star. So it'd be plus, and this is x times negative y, so that would be negative. First mistake I've made in 50 years. Okay, you were here to witness it. Feel proud. Okay, x squared. I'll make another one someday. Minus 2xy plus y squared. 1095 to this. X minus 3 times x plus 2. Distributive law confirms that. Now that should all be very familiar to you. Unless it's been a decade or so since you had a math class. Probably isn't as familiar as it ought to be for most of you, partly because of the COVID disruption. Okay, but we got to have these things straight. Okay, just got to know these things. We can't do pre-calculus unless we know algebra. Now, having said that, we're going to do some pre-calculus without knowing algebra. Okay, we're going to draw some graphs. And you don't have to do these on scrap paper, although if you don't have any other paper, you can. You probably want to, if you got a notebook, you probably want to do it in your notebook. Again, this will be posted. I went over this fast because I'm not going to teach you algebra. Okay. You know, talk about if I'm working me. If I have to teach you algebra, we're not going to learn anything. Don't have time. Okay. So my point is not to discourage you. It's just to tell you. I'd like to see everybody pass this course, hopefully with a good grade. Okay. But you're not going to do it unless you spend a lot of time on it and focus your attention. And possibly think about that MDE 61. Get yourself to the mark. Another thing, I don't know if I mentioned it, I do post the MDE 61 and MDE 60 videos. You know, every day we do videos, and I post them on your site as well as the others. So you have reference to those things. So, okay. So I want you to draw me a graph. Draw that picture from the kind of you don't have to be extraordinarily meticulous about it, but make it fairly good size. Some of these are a little small, but they'll be okay. Now, when you do graphs, you want them to be big enough that you can play with things and see things. Okay, for the most part, this is looking pretty good. If you drew the graph in such a way that you squeeze these points in between here and here, allow to just quickly redraw it so the points are spread out. Otherwise, things are going to get a little jumbled. Okay. If you mark more than 2 points here and 2 points there, or if you mark this axis, that's not what I drew. Okay, no penalty. Just like I do. Okay, for the most part, they look that way. Some of them are a little distorted, and that's not necessarily a big deal. But you don't know what you're going to be asked to do with this, so it's probably best you make it as close to what I drew as possible. Okay. Okay. Now, there's another point on the graph that's twice as close to the y-axis. Okay, you don't know what point that is, but where are the points that are twice as close to the y-axis? Draw me a few points that are twice as close to the y-axis as this one. Of course, this is the x-axis, this is the y-axis. The most common result I saw, the most common thing I saw was like that. Okay, that's right. Okay, presumably these points are equally spaced. Now, if your graph, some of the graphs you didn't have very equal spacing. I mean, this is great. This spacing is a little less than this, right? But these distances should all be the same here and here, here, and here. All right. So I kind of messed it up there. But it's sometimes this one is way too close. Clearly not halfway between here and here, right? So make sure that when you do graphs, you have a uniform set of points along the equally spaced points along the axis. Okay, anyhow, that's a perfectly good answer. If you have that point, that's good. I didn't say so when I saw it. You know, what you had to do if I was gonna say that's good. Nobody really have this. But all these points are placed close to the y-axis of this one, aren't they? Okay, matter of fact, any point on this line here is twice as close to the y-axis. Okay. Also, this point is twice as close to the y-axis. Okay. And so are all the points along this vertical line. Make sense? We just talk about how close you are to the y-axis. Okay. It's like this is a fence. There's a herd of angry bulls charging you. How many people are twice as close to the fence as you are? Well, anybody on this line or anybody on this line, although on this line, assuming the fence will hold the bulls back, you're probably safe, so you probably don't have to do anything. Okay? But all these people have half as far to run as you do. These people just watch and hope that everybody makes it. Okay. Okay, well, there we go. Now, got a rule for you here. When you go twice as close to the y-axis, you get 4 times closer to the x-axis. Okay, so here's the rule: twice as close to the y-axis means 4 times here. As close to the x-axis. Also on the same side of the x-axis. Okay. So if your point's up here, when you move twice as close to the y-axis, you move 4 times as close to the x-axis, you don't go on this side of the x-axis, you stay on this side. So see if you can draw me a second point. Now that satisfies that, put a little circle around that point because you got some other points on your graph. So I want to be able to distinguish it. I'm sorry. Well, twice as close to the y-axis as first, and 4 times as close to the x-axis. There. Then you report to the x-axis. What do you think about the 4 times slope? Okay, it's about half and half. About half of you have a reasonable estimate. And half of you aren't quite sure. So, okay. Remember, twice as close to the y-axis is on this line or this line, right? Because all these points on this line are twice as close to the y-axis as this one. And all the points on this line are twice as close to the y-axis as this one is. Okay? So, of these points, which one, I drew a bunch of points. Is there one that looks like it's 4 times as close to the x-axis? Okay, well, let's vote. And when everybody, no, you can't see where I'm pointing, close your eyes. We're gonna, you're gonna raise your hand if you see other people raising their hand. But we're gonna do this anyhow. Just be honest, quick. I'm gonna point to this point, 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 and this point. Can you tell me which one you think is 4 times closer to the x-axis as this one? Okay? Make sense? And that means raise your hand quick. Don't sit there looking to see how many other people raise their hands. Commit yourselves and vote. Okay, everybody votes. Yeah. Oh, hang on. Okay, here we go. This one. Nobody wants this. Anybody want to vote for this one? Sorry, guy. Okay. And vote here. Any votes here? Yes, we see a couple. Any votes here? I see a lot of votes here. Any votes here? Any votes here? Well, that might well be 4 times as close. It's not on the same side. Might be. Actually, maybe some points over here. Now, the point that I would say is closest to being 4 times as close to the x-axis is this one. Because you take this distance, 1, 2, 3, 1, 2, 3, 4. Probably should be a little bit lower. But this is about twice as close, right? If you run from here to here, you're running twice as far as you would if you ran from here to here, right? Okay. Or from here to here is much closer than from here to here. It's about 4 times as close. I'd say about 3.685 times as close. That's okay. That was supposed to be funny. Okay, got it. Okay, can you show me a point that's twice as close to the x-axis as this one? That's twice as close to the y-axis as this one, and 4 times as close to the x-axis. I'm sorry, could you? I move twice as close to the y-axis. That'll be along this line, because this line is twice as close as this one. Okay. And then 4 times as close to the x-axis. Well, twice as close to put you down here. 4 times as close as you put you halfway between there and there. It's going to be like here. Okay. Now we can continue doing that, but 1/4 of this is going to be really close. So we're going to have a point like here, and then a point like here, and those points are just going to jumble up. But you can see that they're going to approach total closeness to the y-axis And total closeness to the x-axis is here. Okay? And then we can do the same thing with points on the other side. Okay? We have a point here, here. And now we can draw a curve through those points. Not very well drawn because screwed up on this side. Okay. Don't have time to redraw it, but that was, this point should have been down here. Okay. However, it's not at this point over here, and then twice as close, 4 times as close to putting here, and then twice as close to 4 times as close to putting here. So it'll look exactly the same on this side as it looks on this side. Still not very well drawn, but it's a parabola. Okay. There's another one. I'll draw quickly. I also said this is like the y equals x squared function. Because what we study in this course is functions. There's another one that we can draw real quickly. That is, every time I move 1 unit to the left, I get twice as close to the x-axis. And that's going to 1 unit to the left and along this line, twice as close, puts me here. Then I move another unit to the left, I get twice as close to the x-axis. That puts me here. Move that far to the left, I get twice as close again, it's here. And then it's here. And now I've got a graph that looks like this. And this is an exponential. And in a way that we'll see soon, this is like y equals 2 to the x. Now x squared and 2 to the x are easy to confuse, but this graph and this graph are very different. And this graph shows you how fast your money will go. Your money will increase at a constant interest rate. Okay. So that's kind of important if you're business related. You really have to understand that exponential graph. Okay. This side of this graph pretty much tells you how high that rocket will be after a certain amount of time. If this is time, and this is how high the rocket is, the curve is like this, at least for the first, until it's burned a significant amount of its fuel. Okay, and there's physics in that. I'm not going to explain that to you. And a whole lot of other things. In business, for example, I don't want to emphasize business, but thought of turn this thing upside down and move it over a little bit. That curve could tell you the price you should set to maximize your profits. Now, with the help of that idea, that's at the top of the curve. This is the price, or this is the price you're charging, and this is the profit. Or it might well look like that, the first approximation. So you really have to understand and be able to analyze. That's why we study recalculus. 2 examples. Those are business related examples. I can do business related examples all day. You don't want to see those right now. Okay. Fair enough? Okay, do the assignments, get it done. Go talk to the Mark about some of these problems. Get acquainted with what they're doing. And I look forward to seeing you Thursday.
looking to recall. Yeah, but I'm also gonna try and catch that food truck with their house before they leave it too. Okay. I'll just.
Dude, I just saw Austin. Oh, really?
I was just sitting.